Question 445. Let's say we have limit as x approaches a, f of x over g of x. And when a is substituted for x, then we will have f of a over g of a. If this expression is equal to 0 over 0 or plus or minus infinity over infinity, then this form is called the indeterminate form. In such cases, we can use the L'Hopital's rule. Okay, L'Hopital's rule is limit as x approaches a, f of x over g of x is equal to limit as x approaches a, f prime x over g prime x. Okay, so whenever we apply L'Hopital's rule, I'm gonna write L prime right here. That means I applied the L'Hopital's rule. All right, now let's find the limit right over here. If we substitute infinity for x, then that's gonna be infinity over infinity, which is the indeterminate form, right? So we're gonna have to apply the L'Hopital's rule to solve this limit. Okay, so this limit is equal to, here we're all applying L'Hopital's rule. So limit as x approaches infinity, derivative of numerator, let me erase this. The derivative of numerator is 2 times e to the 2x, right? The derivative of denominator, that's going to be 4x, right? Now, let's substitute infinity. If we substitute infinity here and infinity here, then again, that's going to be infinity over infinity, right? So we're going to have to apply the L'Hopital's rule one more time, right? So let's erase this. So we're going to apply L'Hopital's rule one more time. So that is equal to limit as x approaches infinity, derivative of numerator, that's going to be 4 e to the 2x, and derivative of denominator, that's going to be 4, right? Now substitute infinity for x. So if we substitute infinity for x, then that's going to be 4 times e to the infinity, that's infinity, right? Over 4. So that ends up with infinity, right? So the answer for this limit must be infinity. All right? Question 446. We're going to have to find this limit right here, and x approaches 0, right? So what we're going to do is we're going to substitute the 0 for x first. So 0 here, 0 here, 0 here. Then that's going to be equal to sine 0, that's a 0, right? Cosine 0, that's 1, minus 0, minus 1. So that's going to be equal to 0 over 0 in the determinate form, right? So we're going to have to apply the L'Hopital's rule. Okay, let me erase all of this. So this limit is equal to, applying L'Hopital's rule, limit as x approaches 0, derivative of numerator, that's going to be cosine 2x times derivative of 2x, chain rule, right? Okay, derivative of denominator, derivative of cosine, that's minus sine, and minus x, that's minus 1, derivative of minus 1, that's a 0, right? So now substitute 0 for x. So here 0, here 0. So that's going to be equal to cosine 0 times 2 over minus sine 0 minus 1. Cosine 0 is equal to 1, right? So 1 times 2, that's 2. over sine 0 is equal to 0, right? So negative 1 here. So the answer has to be negative 2, right? Question 452. Here we have limit as x approaches 0, and we have this expression right here. So what we're going to do is we substitute 0 for x first. So 0 here, 0 here. Then that's going to be equal to natural log 0 plus 1, 1, right? Over cosine 0, that's 1, right? So 1 minus 1. Remember, natural log 1 is equal to 0. So we have a 0 over 0 again, right? So we're going to have to apply the L'Hopital's rule. So let's erase this. Okay, we're going to apply the L'Hopital's rule. So we have limit as x approaches 0. Derivative of numerator, we have natural log. So that's going to be equal to 1 over x squared plus 1 times derivative of x squared plus 1. Chain rule, right? 2x. And derivative of denominator. Derivative of cosine, that's negative sine. We have x squared times chain rule, derivative of x squared. That's 2x. Minus 1, that's 0, right? Derivative of 1 is equal to 0. So let's simplify this. This is quite complicated, right? So let's simplify this. So this is going to be equal to limit as x approaches 0. We have 2x over x squared plus 1 over negative 2x sine x squared. Okay. We have denominator here, so we're going to multiply by x squared plus 1, x squared plus 1. Then that is equal to limit as x approaches 0. We have negative 2x times x squared plus 1 times sine x squared. Numerator, this cancels out, right? So we only have 2x. And also cancel these terms out, right? So we have limit as x approaches 0, 1 over negative x squared plus 1 times sine x squared, right? So let's think about this limit right here. As x approaches 0, as x approaches 0, let's say from right hand side, then x squared also approaches 0 from right hand side, right? What about as x approaches 0 from left hand side? Then x squared is always a positive, right? So x squared approaches 0, but from right hand side. Does that make sense? Let's say this x value is a negative 0.1. Then x squared, negative times negative, it's positive 0.01, right? It approaches 0, but from right hand side. Does that make sense? So as x approaches 0, x squared approaches 0 from right hand side, right? So as x approaches 0, we know that x squared approaches 0 from right hand side. So far so good. Then what about sine x squared? Sine x squared. Think about the graph of sine. The graph of sine, it looks like that, right? As x squared approaches 0, it also approaches 0, right? So this value right here approaches 0 from right hand side, right? Does that make sense? Now let's think about limit of this expression right here. As x approaches 0, this value right here approaches 1, right? If we substitute 0 here, 0 squared plus 1, that's just 1, right? And this expression right here approaches 0 from right hand side, right? So this value is going to be negative. Remember, we have a negative here, right? Negative, think about like negative 1 over, we have like really small number, like 0.0001. That's going to be really large number with a negative, right? Like that. So it approaches negative infinity. Question 458. The table above gives values of the differentiable functions f and g and their first and second derivatives at selected values of x. Find each of the following. Here we have to find this limit. If we substitute 1 for x, 1 here, then that's going to be equal to f of 2 minus 1. 1 over 1 squared minus 1. So when x is equal to 1, y or f of x is equal to 0, right? So that's 0. And denominator, we have 1 squared minus 1, 0, right? So this limit is indeterminate form, right? So we're going to have to apply the L'Hopital's rule. So let's apply the L'Hopital's rule down here. So the limit as x approaches 1, derivative of numerator, that's going to be f prime 2x minus 1 times chain rule, right? Derivative of 2x minus 1, that's 2. And derivative of denominator, x squared minus 1, that's 2x. Now substitute 1 for x. So that's going to be equal to f prime 2 minus 1, 1 times 2, right? Over 2 times 1, that's 2. So far so good. So that is equal to f prime 1. And when x is equal to 1, f prime is 4, right? So f prime 1 is equal to 4. All right? Question 462. The graph of f consists of line segments as shown in the figure above. The figure is right over here. The question is to find each of the following. So we're going to have to find this limit right here. Let's substitute 1 for x. So numerator, we have cosine pi over 2. Denominator, we have f of 1 minus 1, 0 plus 1, right? Cosine pi over 2, that's 0, over, what's f of 0? Here we have a graph of f, and when x is 0, y is negative 1, right? So the function value is negative 1. So we have a 0 over 0 indeterminate form, right? So we're going to have to apply the L'Hopital's rule. Here, let's apply the L'Hopital's rule. Then it will give us limit as x approaches 1, derivative of numerator first. Derivative of cosine, that's negative sine. We have a pi x over 2 times derivative of this expression right here. That's pi over 2 times x, right? So derivative is just pi over 2. Now, derivative of denominator, we have function f. So that's going to be f prime x minus 1 times the derivative of x minus 1. That's 1, right? So we don't have to multiply by 1. Derivative of x, that's plus 1, right? So far so good. Now let's substitute 1 for x again. So that's going to be equal to negative sine pi over 2 times pi over 2 over f prime 0 plus 1, right? So that's going to be equal to sine pi over 2. That's 1. This value right here is equal to 1. So we have a negative pi over 2 in our numerator over f prime 0. That's the slope, right? Slope of the tangent line. Here we have a linear line segment here, right? So slope is constant. What's the slope? If we look at this point and this point right here, rise is negative 2, run is 1, right? So slope is equal to negative 2. So negative 2, oops. So negative 2 plus 1, right? So we have a negative pi over 2 over negative 1, which is equal to pi over 2. So the answer must be pi over 2. Question 463. Let's find this limit right here. We're going to substitute negative 1 for x first. So negative 1, negative 1, negative 1, negative 1. So that is equal to, numerator, we have f of 2 plus 3. Denominator, negative 2 times f of negative 2. Negative times negative, positive, right? So plus 1 here. What's f of 2? When x is 2, y is negative 3, right? So equal to negative 3 plus 3 over negative 2 times what's f of negative 2? When x is negative 2, that's going to be 1/2, right? Because when x is negative 3, y is 0. When x is negative 1, y is 1, right? So when x is negative 2, that's going to be 1/2. So negative 2 times 1/2 plus 1. So negative 3 plus 3, that's 0. Here denominator, negative 2 times 1/2, that's a negative 1. Negative 1 plus 1, that's 0. So this is indeterminate form. So we're going to have to apply the L'Hopital's rule, right? So let's apply the L'Hopital's rule. So we have limit as x approaches negative 1. Here, this is kind of messy, right? So let's erase this. Okay, derivative of numerator first. F prime 3 plus x times the derivative of 3 plus x, that's 1. Derivative of 3, that's 0. So we're done for numerator, right? Denominator, we're going to have to apply the product rule here, right? It's a 2x times f of 2x. So derivative of 2x, that's 2. We have f of 2x plus we have 2x, and derivative of f of 2x, that's going to be f prime 2x, oops, 2x times the derivative of 2x, that's 2, right? And minus derivative of x, that's 1, right? Now substitute negative 1 for x. Negative 1 here. Negative 1, negative 1, negative 1. So that's going to be equal to limit as x approaches negative 1. Okay, f prime, that's f prime. 3 plus negative 1, that's 2, right? Over, we have 2 times f of negative 2 plus, I'm sorry, the 2 times negative 1, that's minus 2, right? So minus 2 f prime, 2 times negative 1, minus 2 times 2 minus 1, right? Okay. Since we substituted a negative 1 for x, we don't have to write this limit, right? So let's eliminate and let's erase this limit. And let's find the value of this. Okay, f prime 2. What's the slope at x equal 2? That's 0, right? So we have a 0 here. Okay, what about our denominator? That's going to be 2 times f of negative 2, that's 1/2, minus 2 times f prime negative 2. So what is the slope at this point right here? Rise is 1, run is 2, right? Rise over run. So that's going to be 1/2. 1/2 times 2 minus 1, right? So cancel it. Cancel it out, right? So that's going to be equal to 0 over, that's 1 minus 2 minus 1. That's 0 over negative 2, right? Since the numerator is equal to 0, the answer is 0, right?